That's got to wait a second because I got to make sure that it's got up to 100%. All right, good. All right, so we can see that somewhat. Does anybody want to move down the lights, or can you somewhat see this? I'm going to bring up Management Studio in a minute too, but I'll make sure I zoom in on certain things that I want you to see. If everybody can see, that's fine. Otherwise, the lights are on that back panel. Try to dim them a little bit. I don't want anybody to fall asleep, but I also want you to be able to see. I apologize that it's up here. Like I said, we couldn't get the small one, so it's got to be up here. I think there's a master one that you can dim. There we go. That looks better? Yeah. Okay. Now, I also brought treats in the back, of course, but if you want, for good questions and good conversations, I have candy bars to throw. I do like to throw these, though. So
dim the lights.
Yeah, if you're falling asleep, you might get hit with one. I will do my best to not hit anybody with a...
What if it was inconspicuous and that was thrown ahead of time?
Yes. All right, so we are going to talk about performance tuning queries today. That's what we're going to be talking about. About me, I really don't like to talk about me, but you're welcome to read my slide. I've been doing SQL Server for a long time. I like to do photography, and I like to put on events. That's basically what I do. Oh, you know what I forgot to mention was the event, Utah Code Camp this Saturday. That's right, this Saturday. It's going to be a big event. We're planning for 500 to 600 people at least. We have, I think, 67 sessions or 70 sessions, something like that. It's going to be a full day with a lot of great technical learning. And there's a great bunch of database topics too. There's a bunch of data analysis and data mining topics as well. So go check it out, utahgeekevents.com, and the schedule's been updated as much as this morning. It gets updated pretty much every day. So, but definitely go out and check us out, utahgeekevents.com. It'll be going on this weekend. I don't have my email up here. Everybody should have my email. It's the one that you all get the newsletter from. If you ever need to get a hold of me, just respond. All right, so what we're going to talk about is performance tuning queries. And this works. What I've done is I've kind of set up kind of a little task list of all the things you should think about whenever you're performance tuning queries. So I'm not going to just show queries and how to performance tune them. I will show that as well. But I want to talk about all the external things that you got to talk about as well when you're talking about performance tuning queries. Because there's more than just, I've got a query that's running slow. There's more to it than that. There's always architecture, there's always design, there's other things to think of. So I'm going to go through this list. This will be one of those few times I like to read my slides, but check for external issues. I think my next slide, yeah. So check for external issues. What are some of those external issues that you run into? Blocking, that's one of my favorite ones. A query may be running slow just because it's being blocked by something else. How many people like to use who is active? Okay, not everyone's hand is up in the room. Everyone's hand needs to be up. There is no better tool on this planet to show who is active than who is active, okay? There is no better tool to see what's going on your SQL Server right at that time than who is active. Everyone should be using it. And you should get more familiar with it. I've learned a few new switches and flags for it that are really helpful. So if you haven't read Adam Macknick's blog on it, please do so. Kendra Little, right up on it as well. So if you look for Kendra Little and who is active, she does a whole bunch of great training on it. Really, really helpful.
What's the difference between SP
Okay, SP Who 2 is like, I want to put this properly. SP Who 2 is a Yugo. This is a Bugatti Veyron.
Yeah, it's like SP is like a big wheel.
Yeah, it's so SP Who is active basically just gives you everything you need. Who 2 is like, oh yeah, SQL Server wrote something to show you what's going on, and that's about it. So yeah, I haven't run a Who 2 in like 2.5 years, I don't think. I mean, it's been a long time. Well, I ran it. I was in someone else's database that I have access to, and I didn't have Who is active. I didn't want to install it, so I like, okay, I did a Who 2. But that's it. It should never be used. Who is active is the answer to everything for that. External checks, poor disk I/O. If you have high latency on your disks, this could also be slowing down your queries. Again, we're going to go into the exact things to look for, but these are all external things you should think about when you're performance tuning queries. Don't just think about the query itself. You have to think about what else is going on in the SQL Server. One that I don't put on here, oh, I do, not enough memory. PLE. Does everybody know what PLE is? No? Okay. Page life expectancy. PLE is the page life expectancy. This is the number of seconds a page will live inside memory on your SQL Server. This is one of my favorite metrics because Microsoft got it completely wrong. I love to talk about this. Microsoft said, hey, anything above 300 or below 300 is bad. And they made that blanket statement. It's in books online. It's the dumbest statement Microsoft's ever made. It's back to, hey, nobody will ever need more than 640K. Because the answer is really that 300 seconds isn't an indicator that something's wrong or not, depending on the size of your SQL Server. It all depends on what you normally do and how you do it and all sorts of different things. So, but think of it this way. If you run a select query, say I run a select star from users and it loads 10,000 rows, it just lowered my PLE by a little bit, most likely, if it's not already in there, because it put data into memory. It put data into the cache. Now, SQL Server is going to take that data out in X amount of time. No one can tell you exactly how much time because it depends on how much is going on in your system, how many other queries are coming in, what's being pushed in and out. So, but if you look at PLE and it says, I'm only going to hold it for 300 seconds, that's 5 minutes, that's a pretty good amount of memory pressure. That means it's not going to hold that data very long. You should have PLEs that are much higher. And the person to actually tell you the real number is Jonathan Cahias. If you search for Jonathan Cahias, PLE, he gives you a calculation. He actually gives you a number calculation that if you're running at this, you're probably okay. Now I say probably because it depends on your own situation. You should always look at your own SQL Server, do a graph on perfmon or whatever you're using to monitor that, and make sure you see what your PLE looks like. Your PLE will take sharp dives down. Somebody runs a big giant query, loads the data up, all of a sudden it'll take a dive down, but then it'll come back up. It's always going up, really, almost always, because it's the number of seconds that it's going to leave a page in memory. So it'll either go up to a point and flatline, and that's okay, or it'll drop down and then go up and then drop down and then go up and so forth and so on. Does that make sense to everybody? Every time you run a query, you're going to affect your PLE, unless the data is already in memory, which that means you affected it earlier. Does that make sense? So PLE, go back to your system, look up page life expectancy. It's under the memory counter, I think, under SQL Server. I'm trying to remember the exact spot. We have ours, we use Zabbix to monitor. We have ours in Zabbix, we have an alert for it. If it goes under a certain number, it sends us an email and says, hey, your PLE is bad, and we know to look at our servers because of that. So if that number is really, really low and consistently really low, and you're gonna have to define what really low is, but if you're consistently really low, you need to add some memory to your SQL Server. Memory is one of those quick wins that you can get by adding memory to your SQL Server. Okay? Yes?
I look at this as bus speeds too. So you've got poor disk IO on there.
Yep.
Not enough memory. I mean, how much memory do you need? More.
Right, always.
And so if you're trying to access data that's already in memory, it's so much faster. For a few years now, we've had memory controllers on the CPU.
Mm-hmm.
So trying to access data that's already in memory is much faster than trying to access it over the PCI Express bus, whether that PCI Express bus is attached to storage or to a network card, or the SAS bus or a SATA bus.
Right.
Much faster to just grab them.
Yes. So Lars' point, to make sure everybody hears on the recording too, is you should always have just about as much memory as you can, really, so that because it's the fastest way to get to the data. In memory is really the fastest. Now, the cool thing is that up to a point, SQL Server is going to use that and it's going to love you for it. But at some point, there's certain buffer pools and there's certain pools that don't live inside memory. They live on disk or other things, so they still go to disk. So someone always asks me, why can't I put my entire database in memory? Well, because SQL Server isn't designed that way. You can't just shove an entire database in memory, even if you have it. Let's say you have a 500 gig database and you put 2 terabytes of memory in a SQL Server box. Why can't it all just live in memory? Well, because it's not designed that way. You can't just load the whole thing into memory and leave it there. It won't work. But you can move as much into memory as you're querying and doing these things as possible. And that's what Lars' point is that you should always have a high PLE number, really. You should always have 60,000 plus, 100,000 plus, whatever, so you don't have that memory pressure. You don't want to take the chance. Memory is a lot cheaper than disk. So focus on making sure that number's up. Did that summarize pretty well, Lars? Okay, I just want to make sure everybody on here hears it because they won't hear you. So Poor disk IO, I didn't talk about that too much, but disk latency, check your SAN, check your disk queue lengths, these sort of things. If they're running slow, you're going to run into problems. That all depends on what your SAN architecture is, but check with sysops and see what they say. These are all things you should check on, as well as performance tuning your queries. Because you could performance tune it, you could make an index seek, and it's only looking up 100 rows, but it could still be slow because you don't have memory or disk to actually do the work. So these are external things you should look into before really looking further into that. Okay, questions, external. Anything else anybody wants to comment on other external items? Other DBAs don't count. If they're causing you performance problems, well, that's a bigger discussion that we can't have right now. Yes.
A while ago, I ran into this problem and ended up finding a solution, just adding more channels. Most of the infrastructure people that I've worked with, they insist that one channel to the SAN, if your machine, is enough. But I know it's not, and you end up having, and then they have, but it's two, but it's active and passive, which in essence you just have one.
Right, right.
Then the VNC, the VNX sender, I had this, I don't know, EMC has the software that allows Windows to use more than one active. Right. And it alleviated a lot of the pressure. And I mean, IO performance improved by 30% by adding a second active channel. Right. But it's just that I can take a look at, for instance, performance monitor, and I can see the disk queue, I can see the disk percent utilization. But how do I go back to the infrastructure guys and tell them the problem is not the SAN, the problem is not the box, but it is the channel that is talking to the SAN. Does that make sense? Yes. So Alex's point is that it's very, very hard to tell sysops or operations or whoever's managing your SAN that you have a slow SAN when they've been rated for 10 terabytes a second or something, some insane number. They say, well, there's no way that you could be overtaxing our system. Our system is perfect. There's no way you can do this. But the little straw between the two systems can have very big issues, and they have many times. I know cards in the past that used to burst and then make my clusters fail over because they had a rating of 200 megs per second, even though the card was at 2 gigs per second. So the point to this is that Alex's point is that you have to go to them with perfmon data. You have to go to them with try to show data that shows the issue. And the best thing I can suggest is what I always kind of tell people: in God we trust, all others bring data. So in other words, you have to somehow convince them the data is what is there. Show them a slow time. Show them when queries run slow at that time, and show what the disk queue length is at that time. And make sure you instruct to them and you explain to them disk queue length is the amount of time from SQL Server essentially to whatever I went to and back. That is the amount of time I waited. Now, I can't tell you that your SAN is running slow, but I can tell you my SQL Server is waiting too long to get data back. You have to tell me where in that path that actually happens. Maybe it's the straw, maybe it's the disk, maybe it's a controller, maybe it's something else, but that's what you really have to try to do. The other thing I always suggest is that if you can, benchmark your SAN before they put it into production. I love to IO stress test my SANs before they're ever allowed to touch SQL Server data, because then I know what they look like without anything on them. I know what their numbers should be no matter what. And then if I run that again, when all the SQL's there and other people are running, I know those numbers that I should be able to get. So if you can benchmark your SAN before it ever touches production, you have a wonderful benchmark to use. So those are some of the things I've used. And basically it's all a matter of, really getting the baseball bat out and hammering it over and over again. Because again, the biggest things to avoid is don't say the SAN is slow, okay? Or don't say their disk is slow, because you know what? It's probably not, but the pipe between it could be. So say something like, I'm seeing slow times from getting my data back from the disk. I don't know where that is. Can you help me find it? That sort of conversation kind of helps move that along. If you just say your SAN that you just paid $3.5 million for is slow, they're going to say, no, it's not every time. So keep those things in mind. That answer your question, Alex? Great point to make. When it comes to poor disk IO, I cannot stress enough how well you need to be friends with whoever your operations is, whoever your SAN administrator is. Take them to lunch, whatever you have to do. You have to do something, because I guarantee you, if you say the SAN is slow, they'll say, no, it's not. And you'll have a battle on your hands. You have to find a way to make that middle ground
and have them understand there's other pieces to this system besides just the sand. And again, talk to any EMC guy, any Hitachi guy, anything else. Our sands can do anything you ask them to. Well, yes, they can, but if they're not designed properly, or if they're not set up properly, they can't do anything. So, okay, anything else on the external checks? All right, my other favorite thing to talk about on query plans is set-based versus procedural. How many people know what procedural means? Okay, kind of a quiet group. Come on, you can shout it out, I don't mind. Row by agonizing row, procedural. Usually this is what code does. If I see the color is blue, then I go and I write, I love the color blue into a table. And it does this one by one for every row in the table. That's procedural. Most developers, most coding technologies use procedural-based logic. They do not use set-based logic. Most databases use set-based logic. I see that in the table there are 5,000 rows that have the color blue, so I'm going to go insert them into another table. That's set-based. So you have to keep in mind as you're looking at queries that if your developers are the ones writing it, or if somebody that does a lot of coding is writing it, most likely your procedures will be in procedural logic, and they will run slower because they're not set-based logic. So whenever you can, try to look at the procedure and say, okay, why is this cursor here? Why is this while loop here? Do I need to update every row one by one, or can I do this in a set-based manner? Because set-based for the database is going to be much, much faster than procedural-based, okay? And that's just something to look for. So when you're looking at a query, I always tell people, look for cursors and look for while loops, because those are forcing you to go row by row to do something. Maybe it's not bad. Maybe it's calling a function that all it does is mathematically add two numbers together. Fine, that's probably not gonna be that big of a deal. But if it's pulling one row out of a table, doing something to it, and then pushing it into another table, you can probably do this set-based much, much faster, okay? So keep those things in mind while you're looking at these. I think I went over all of those things, slow for lots of data. Now, there is some disadvantages to set-based functions or set-based pieces. One, you can't really do like row by row logging of what's going on. You have to do a logging for that set. Or if something fails in the set, the whole set usually fails. Okay, so some people will say to me, well, we've got to process one by one because we want to know every row and exactly where it failed. Then you probably need a procedural logic. There are some people that I've seen use a set-based correctly for that, but it's not simple. Okay, definitely that's something you've got to work on, doing different sets. But if somebody said to me, I've got to know every record that I just parsed on this file and exactly where it failed and how it failed, you're probably going to have to do something procedurally because you need to know every row by row. Okay? Questions on set-based versus procedural? The other thing I'll mention is functions here. So functions are a wonderful thing inside code. They're used, they're classes, they're wonderful. In SQL Server, they're a nightmare. Because what they did is they named them the same thing. So I would have loved to tell Microsoft, look, name them something else. Because I have tons of developers that say, oh, I can write a function. And they write this big complicated function that's 1,000 lines long, and then they stick it into a select statement. Okay, so what happens when you stick it into that select statement?
Procedural automatic.
Yeah, well, it's not only procedural, it's not only row by row, but it does it for every returned result set that you have. If you join 5 tables and they return 10 million rows, it's doing that function on every row that you have. That's what a function does inside SQL Server. So it's a very, very dangerous thing. Yes?
That's not the case for table value functions.
That's correct. Now there's new ones and they have different names, but do all your developers know the difference? No.
Do you have developers that write table value functions?
Right, yeah, do you have developers that write table valued functions? We have a lot that don't. And so you're absolutely correct. And table valued functions are wonderful. They're a great piece of work. They're wonderful to use. I'm talking about the functions, scalar valued functions that people put directly inside a select statement. If you see those, question them immediately. Question the function, not the person. The function. Go to the function. If the function is doing nothing but a mathematical job, that's not a big deal. But if it's pulling data from another table and then doing something to it, you're going to have problems because it's going to do that for every row in your join statement. And when I say join statement, I mean every Cartesian join statement, in other words. Virtual table A, B, C, I'll show you this in a second. All of that data will go through that function, okay? So it's really not a good thing.
And if it's doing a lot of crazy date stuff, get a dates table.
Yes, if it's doing a lot of crazy date stuff, get a dates table. It's where functions, you can use things like numbers tables or date tables to get away from using a function inside there. If you have a value or something you need to look up, use a table that already has that value. Now there's limitations to that. If you're talking about you're gonna put 2 billion rows in it, that might not help you. But if it's something that can be reasonable, it might be a much better way to do it. Or like I said, just don't try to transform data inside a scalar valued function. You should not transform data inside there. Well, okay, let me rephrase that. You should not transform it if you pull it from another table. If you pass in a value and then say times all of these values by 10, that's not a problem. That's fine. But if you say pass this value in, pull it from another table, combine these two together, and then return it to me, that's a problem. Okay? Does that make sense to everybody? On functions? So functions are not inherently bad. They're really, really not. They're just used wrong a lot. Okay? It's one of the first things I check for inside queries is functions, because 9 times out of 10, the developers think they're a great way to do it, just like they did in code, but in reality, they're not. They're really bad for SQL Server most of the time. All right, query plans. So I'm gonna bring up a demo for this query plans, and then we can talk about more of these things too. But I'll go over some of these things really quickly, and then I'll show you on the demo as well. It'll be a lot easier if I kind of talk through them really quickly. Follow the fat arrows. This is my favorite saying. This is what I talk about all the time. You don't want to just look for, hey, who has the highest percentage? Because if you actually follow that fat arrow, you're going to find where all your data is. And I'll show you that to you in just a second. Sargable versus non-sargable. Does everybody know what sargable is? No, I see a few heads nodding no. Sargable stands for search argument. It means that you are sargable if the left-hand side of your query or the right-hand side of your query is constant. So I'm going to show you an example of this, but basically if you said something like tax number equals 10, that's a sargable query because it's a constant on the other side. If you said tax number equals this variable times 1.5, that's not sargable because you're doing a calculation to figure it out on the right-hand side. And what is the difference between those two? Sargable will have an index seek. A non-sargable will have an index scan. It will scan the entire index because you are not giving it a constant value. Okay, so those are the things to keep in mind. I'll show these to you. Percent cost, look for things about scanning. I'm just going to go through these now. Okay, how many people know the tool that I've just brought up? Okay, again, everyone's hand should go up. SQL Sentry Plan Explorer. There is no better way to look at a SQL Server query plan than the Plan Explorer. These guys have created a wonderful system.
And it's free.
And it's free, and you should totally use it no matter what. So.
And teach all your developers to use it.
I don't have anything. Let me pull up my DP and see what I actually have in here. Baseball data. Oh, good. What did I call that? I'm so used to being in. I want to do show tables, but I'm not in Hive. I haven't been in SQL as much for a while. This is what happens when you're in other systems too much. Okay. So, simple execution. I'm just going to show you all the things to go through. Execution plan, it's right here. Okay. So, your execution plan on SQL Server, all I did was click the little button up there. You can do Control-K, Control-L, I think is the other one to turn it on. I always hit the little button right up here to show your execution plan. This will give you good information. As you can see here, it'll tell you all about it, estimated cost. But really, when you start playing around with lots of queries and lots of big queries, Plan Explorer is the way to go. Simple as that. Don't even keep looking at Management Studio, just go to Plan Explorer. And the way you do that is, unless you buy it, if you buy it, you can do this directly inside it, but I use the free version. You go right here, you say Save Execution Plan As. You can see I have quite the history. These are all my execution plans that I've saved before. I can't show you all of these because they're different products that we use, but if I save this plan, and then it gives it a name, Then when I go into Plan Explorer, not Skype, I can just open up that plan. Again, this is a different directory I'm using for this demonstration, but you can see the plans right here. When you open up these plans, this is what you get. This is a much, much better way to look at things. It not only tells you your high percentages, it tells you your IO right here. If you have multiple queries, which I'll show with this one, you'll see multiple queries inside here. See how there's lots and lots of them? This one's a loop specifically. So if I had multiple queries, it'll show them all inside here. And for each query, it highlights. And if you're in a big batch, it highlights exactly where you are in the batch. So as I click through these, you can see it's changing to different places. So you know exactly which one. So over here on the right, when you're looking at this and you see estimated cost, let's go back to another one. I'm going to keep jumping around between these. When you see these estimated costs and you want to see which one is the biggest, you can click on it and then you can look at the text data inside it and you can see exactly which query inside that batch is really causing your problems. So again, I cannot stress enough, Plan Explorer is the way to go. Don't question it, just use it, no matter what, okay? So now let's talk about the things we run into on a plan. Let's talk about some of the things I was mentioning. So when you start getting to this graphical plan, there's some key things that you want to look at here. You want to look for the word scan. Scan means table scan, clustered index scan, some sort of scan. Those scans mean that you're scanning a whole table, a whole index. You're scanning a lot of data. You always want to try to seek data. And why you want to seek it is because it's much faster than scanning data. Now, every once in a while, you'll get a case where the table, you scan it, and it's not that big of a deal. Maybe it's got 100 rows. It's 100 rows. It's not going to make that big of a difference to seek it. So it may not have any advantage to add an index to it, but you should still look for the words scan. The other ones you should look for is key lookup and bookmark lookup. Those are my two favorites because those are where you can really gain performance very quickly. And the way you would see them right here. A key lookup means, let me see if I have one really quick that's on there. I'll try with this one. This one's bigger. Yeah, right here, key lookup. So let me get rid of that. No, I didn't want you over there. Okay. There. Key lookup right here. So what this means, this key lookup, is in this index right here, it found the data it was looking for. It seeked it. I had a where clause. I said where this column is equal to 10. And it found the data for me, but my select statement needed to pull back more columns than what was inside that index. By needing to pull back more than what was in that index, it has to do a key lookup. Found the data, it's got to go to another section, another page, and pull up the data that's involved. So you fix this with covering indexes, or redesign your system, but that's another bigger story. But a covering index will be an index that I'd modify this index right here, and then I would go to this key lookup and I'd say, okay, what's missing? And it'll tell me, thanks to Plan Explorer, if it'll show up. There we go. Right there, output list. Can you see this? Respondent ID. So it wants me to put in a respondent ID. So if I made an index that said, I took this index, whatever these columns are, and I said include respondent ID, I would remove this bookmark lookup right there. And then it wouldn't have to go off. Now, these make huge performance improvements. I've seen queries drop from minutes to seconds with things like this because it doesn't have to go somewhere else. Because you've put the data inside the index and that makes it that much faster. Now, what did I just say that's very, very wrong? Anybody? Somebody wants a candy bar. The data's inside the index. Mr. Goodbar to you. So what does that mean for the data that's sitting inside my SQL Server?
That means it has more.
Yes, it has more.
Store more.
And it not only has more, but your data, your indexes are going to get bigger. You're going to have more maintenance on them. You're going to have bigger sizes. You're going to take up more space because you're kind of duplicating your data that's sitting in the table and that's in the index then. So I call this my sins because I've created a lot of these to cover these things up. That's why I said, This will give you great performance improvement. If you just went to a query and you found all the key lookups and you replaced it and you put covering indexes on it, your system will speed up, I guarantee it. But you will have more data inside your indexes, you'll have more maintenance time, you'll have more insert and update time on those indexes as well.
And you'll need more space for your data.
And you'll need more space for your data. So this is a trade-off. The real solution is re-architecting your system so that you change the indexes so that you only query what you need for, make your developers say, okay, I only need these columns, put an index on those columns, and that's it. If you're like me and you have hundreds of these queries running around, every developer has written the select statement differently. So I've got 3 columns in one, 2 in another, 5 over here. So if you have to index for that, you may have to have 1 index for that, 1 index for that, 1 index for that. Try to get a consolidated view, because whatever is in your select statement, that's what it's trying to look up, okay? Does this make sense to everybody? Let me open up the plan. I'll show you on this. Yeah. Ooh, what did I do? So what I mean by this, and I'd rather show it on this than one of my other queries, right here, name and state. So all I'm pulling back is name and state. But if I had another one of these queries out there that said name, state, and address, name, state, and zip, name, state, and something else, or maybe it said address, name, state, or maybe it was different orders. If I've got 50 of these different things, SQL Server can't index them properly. And you could end up with 10 or 15 different indexes, or 5 or 6. You could end up with a lot of different variations. So the more you can get these queries to be very similar and to look similar, the better off you'll be. Let me show that a little closer so everybody can see it. But the column order is very important to SQL Server. It dictates the index order when you create these indexes, okay? So keep that in mind when you're looking at these queries or when you're writing these queries. It's not just a simple, hey, I'm doing these columns. You've got to be concerned about the order as well. It's very important.
Do you have a standard that you use for your developers?
No, you can't really create one because it's per system. I mean, I couldn't say every customer table you must select like this. It just, I don't think that could really work well. Mike, do you got to?
The minimal is you can tell them, please put the column you select in the same order there on the table.
Yeah, I mean, if you can get to where you're using the same column order for the table between queries, that's probably as close as you're going to get. To make a blanket call and say, always put name this way, I mean, there's way too many tables, way too many variations of names. Yeah. I would just try to focus and teach people that a lot of people don't understand that is important. Those columns are important. They just think, well, I'm just grabbing data from the database. I'll put it in whatever table I want and the way I want. They don't know any differently, so educate. So, okay. What else was I going to mention on here? So, Sargable. This query is Sargable, okay? It says state equals Utah. If I changed this, which I can't do right here, if I change this to say state is like Utah and put a % at the end of it, it would still be Sargable. I'm getting ahead of myself. So if there was a % right here, it would still be Sargable. The reason is that if you say starts with, that's still a Sargable query. You can still index it properly. You can still seek the index. As soon as you put a % sign on the other side of it, like % Utah %, you want to find everything with Utah in the middle of it, it's a scan, period. It's always a scan, okay? So people ask me a lot about dates. You know, how do I send my start date and end date? If you want to send a start date and end date, make sure you say you don't do, I'll put it in Management Studio so we can see it easier. So if I wanted to, there's not even a date in here, but if I wanted to say insert date is greater than or equal to date add dd -2 get date. That's what I don't want to do, okay? The reason I don't want to do that is it's calculating that get date. It's going to help it force a scan because I'm trying to get the date. What you should do to get around things like this is, oh, I just lost my connection. And then set, all right, I said set. I should have said declare. My mistake. Equal to.
Everything today.
Yeah, not actually equal. So something just like that. You want to set it at the top so that it becomes a constant value when it's passed to the query. Okay, so SQL Server can evaluate it beforehand, set the constant value, and then query the value. You don't want functions, you don't want to do anything on the right-hand side of this query. Right here, you want this to be a constant whenever you get a chance. Like this. Oh, why am I doing this? This is why you don't type in demos. Okay, you want it to be constant whenever you get a chance. If you do the date conversion, if you do anything else. Now, what do I mean by the joins make a difference? So down here, you can see there's several joins in this query. When I do a function, or when I do something on this, SQL Server is creating virtual tables for C, CE, and that other, do I have another CE? C. So C to CE, virtual table A, CS to CE, virtual table B. Then it comes back together and makes virtual table C. It's doing this in the background. That's what you see inside the execution plan right here. Seeking data, bringing them together, looping join, bringing them together. When this fat arrow comes together with the rest of it, if you have a function there, it's executing that function on the fat arrow, not on the little tiny ones. It's doing it on the fat arrow. So what that means is that you've now just taken and said, okay, I've got two small tables, but I've got one really big one. I don't want to do the function on those. I just want to do it on the small tables. It's not going to do that because you didn't tell it just on the small tables. You've given the function must figure it out for all of the tables because before it can join, before it can turn it into that small thing, it has to know what the answer is. Yes?
You put your function in the CTE, is that make focus on that query instead of the...
So the question is, if you put your function inside a CTE, does that take it away from the entire join? Well, yes and no. I mean, in other words, are you saying that when I say function, I mean a scalar valued function. So you're saying you have a create function and then you have a CTE inside it? Or?
Let's say a function for non-numeric characters out of a certain field,
Right.
right? You create a CTE that's just going to be a simple select the values you need, put your function inside that CTE, later call that CTE back to your joins.
Well, no, because then, so your CTE is basically becoming a temp table. And when you then pass that temp table to the rest of the joins, you have a smaller thing. So then your function is acting on your smaller temp table. Is that what you're, yes. Yes, so, yes. Yes, so what you're saying is that if you can get your function act upon, so let's say we take our big fat arrow here and we do customer schedule and we do the function on that table beforehand, either through a CTE, a temp table, table variable, whatever, do it beforehand and then pass it to the joins, that's correct. That's what you should do, yes. But if you just type it into here, if you say select top 1000 name, state, and then function, you're gonna get all. And yes, exactly what you're suggesting, CTE, temp table, table variable, do something beforehand before it gets to the big monsters of the join. That's always a good idea. Pre-do it so that when you get there. Because you gotta keep in mind that SQL Server was designed to do 90% of the stuff very well, and it does it very well. But when you get into 10% or when you get into a join like this, you have to help it along. You know, don't join unnecessarily when you don't have to. If you can move it into a temp table and you can control what data it's being passed, you'll always get a better advantage, okay? So the first rule of performance tuning, really anytime you have a query like this, is breaking it apart, starting to pull pieces out and put them into temp tables or do things on separate. If you break it apart, you'll get a better response out of it. You know, as much as we love set-based, if you join 10 tables, I guarantee you it's not gonna be as fast if you separate them out and do them separately, okay? All right, so other things to look for in here in Plan Explorer, fat arrows, startable queries. Let's see, what else did I want to mention in here? Key lookups. I'm trying to think of what are some of the other ones that I love to bring up. Let me go back to my slide. Scanning, conversions. Conversions are another favorite one. So if, this is one of my favorite ones too, because people will do things like this. As A join table B, and then we'll say on A.ID is equal to B.convert to character 2. And then they do B.ID and that. What do you think that does? Yes. Both sides. Loves to scan them. Yeah. Yeah, it'll scan it no matter what you do. Because before it can join, it must figure out every value in the table equal to that. This is one of my favorite ones that people love to do. They love to think, oh, I'm just going to convert all this stuff in the join. No, 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 no. Do this beforehand. Do this in a temp table. Do this in your table. Do something. Don't put this directly in a join. It will slow you down. Yes, sir.
And it's not just convert, it's.
No, it's anything. It's the same sargable idea. Anything over here that is not sargable on the right-hand side will scan the table. Okay. So if I did a really crazy thing and said anything that's like b.id or something like that, it would do the same thing. Anything that I'm trying to think greater than or equal to.
Not equal to.
Not equal to. Oh yeah, don't do a not equal to. That's really bad inside a join too, because you're definitely going to be scanning then.
What if you put that does not equal in the word clause? Is it better or is it the same thing?
Well, you're still going to join on whatever your ID is, but then you got to know the order of operations. So the order of operations for SQL Server is always join first, make these tables, and then apply the where clause. And then apply groups and sorts, and then apply your select statement too to the top of it. So when you join, it will join the tables, it'll put them together, and then it'll apply that where clause. But if that where clause directly goes against the join, you're going to force yourself to scan. So if you said a.id is equal to b.id, and then for some reason in the where clause you said where b.id is not equal to a.id, yeah, you'd scan anyways. It would get very confused at you because it would pull back all the data, it would make a virtual table, and then it would start going through it and say, okay, now who doesn't match? And it wouldn't find anything. So you definitely don't want to move that down to the where clause. Yes, Mike?
I have a question.
Yes.
Let's say your word clause had a where b.ad in, and it had a subselect of a sargable.
You bring up my favorite subselects. Okay, so in select ID from pound, something like that, right?
Yep.
What are you asking? What does that do to it?
Yeah, I mean, that's the select will return the same thing every time.
Yes.
Is it going to do it for each round, or is it going to only do it once?
No, it'll only do it once. So again, order of operations. Order of operations will be, it'll do the two joins. You'll have virtual table B out there, or whatever they want to call it, virtual table X. And then this where clause will apply to that based on that, what you just told it. So it'll take those IDs and say, oh, you got to be in here, so I'm going to remove everybody that's not in there. So subqueries are both wonderful and terrible. They can be very terrible because they can go off into their own execution plans where they do a lot of work. You have to be careful about how far you go with subqueries and things like that, but they're not necessarily evil by themselves. Something like this is not that big of a deal.
What if you put that same subquery in the join?
You don't want to do that.
Okay.
Yeah, you'd prefer to do it in the where clause if you can. Did you have something?
Just for fun, I came across some of the case when statement that they're running.
Oh yes, a case statement inside a join. Inside a join?
Yes.
Okay, so years ago, so the point was case statement inside a join.
It was the previous guy, they were gone.
Yeah, don't do it. So I actually, really good thing, I came across back consulting years ago. They made where clauses that were literally 300 lines long of a case statement inside the where clause. Now, first of all, I didn't even know that was possible at the time. I thought you can't put a case statement inside a where, but you can. And somehow it worked. So, but I do not suggest it. It was very, very hard to performance tune. It did not work well. And so, yeah, keep things like case and stuff out of your join clauses, out of your where clauses. Do all that work beforehand, put it into a temp table, a CTE, a table variable, something, and then put it into the statements and join to it. Remember, SQL Server databases, relational databases are really good at joins, so let them do their work. Don't make it harder on them, okay? Great point. Yeah, keep case out of there.
How much does it tax the join to put an and on there?
To put an and. Okay, so ands. So let's say what we do. Now, are you thinking of another ID like b.text equals a.text or whatever?
Right, yeah.
Or are you thinking and b.id is equal to 10?
Well, either one. I mean, the 10 would be what you're saying with these articles, so wouldn't that be okay, but the other one, would that cause problems?
It is, but there's some caveats that you got to be concerned about here. Again, we talk about order of operations. So, and b.text equals a.text, if you're just doing another column, you're perfectly fine inside a join statement to do another column. Just make sure they're both indexed. When you're joining, always make sure your columns are indexed that you're joining on. That definitely helps your join. So if you did ID and text, make sure there's an index on both those columns, okay? Otherwise, it's just fine to put and put multiple things in there. I mean, definitely if you get to 10 or 20, it's gonna be a pain, but it can be done. Now, when we talk about b.id is equal to 10, that's actually a good thing and a bad thing. It's a good thing because it can limit B right there. So you can, when I said A and B come together to make virtual table X, A and B are gonna come together and B is gonna be limited right there because you've done that 10. So its rows are gonna be limited and virtual table X is going to be smaller. But here's the problem, order of operations. If you put that inside the join statement and then your where clause overrides what you just did, it can put data back into your join, okay? And I've ran into this, and it can return something that you don't expect.
So is it better to keep that equals in the where?
What I have tried to do is I try to keep them in the where clause for my own sanity to make sure I don't have to try to look it up. But that does not mean that I have not put this in place many times because it was necessary to help with performance. You have a question?
How would it put data back in?
Because the where clause is done afterwards. And when it evaluates that table again for 10 or for whatever you've put in, if it found a non-10 inside there, let's say the join took out everything that was 10, but then you said in the where clause it's greater than 11 or something like that, it would then put an 11 back in your join. And then you would get a result that you don't expect necessarily.
Because we do
Yes.
this all the time, but we have queries, we've got a ton of data, and everything's indexed on the dates.
Right.
We'll narrow things down and then narrow it down again.
Right.
But in our join, we narrow it down instantly, just.
Yeah, I'm not gonna say this happens terribly often. It definitely does not. But yeah, it's kind of a bug, but it's kind of not because again, it's the order of operations.
It's just gonna let-
Joins are done first, where clause is done next. So logically, it has to do exactly what you asked it to do. So that's the only time that I ever question when I see a join clause with lots of numbers inside it and stuff like that, I question. I go look at the where clause and I say, is there anything that's gonna try to put things back? So the better rule to live by is do it in one place or the other. Don't do it in both. Don't put B in the join and down in your where clause. Put it only in one or the other and leave it at that. Yes.
One thing you have to remember though is if you're doing a left join,
Yes.
it needs to be in the join, otherwise it turns it into an inner join. You have it in the where clause.
Yes, that would be correct too.
If you're dealing with the,
Yeah, if you're dealing with the outside of there. So like I said, there's some of those quirks, and that's exactly why I bring up points like this, is that you have to be careful when you put things in these join clauses to make sure you understand where they're coming from. So it's all those little minor quirks that always somehow show up in my code somewhere. So
You're the lucky one.
I am the lucky one. Yeah, I've ran into this for some reason so many times. Yes.
So,
I'm
I've run
throwing
into a
one.
couple of situations where they're still using NC time.
Okay, here, candy bar.
So how does that work with the word tables?
Okay, say that again. Where they're still using ANSI
So
9,
instead of a join condition, they just put.
they do star equals and they do commas?
Yeah.
Yeah.
And then all of their join conditions are the where, which.
Yeah,
I
so-
do test just for readability, but they insist on doing it anyways, so.
Now,
Is there
hold
actually
on.
a performance difference? Assuming that it's all inner joins.
Okay, yeah, if not, you would get these wonderful, glorious things. Star equals, or star equals for that way. This is a left join.
Ah,
That's a left join, and that's the right join. Yeah. So, okay, first of all, we can't be too upset about this because it is the ANSI standard. If you go to other database platforms, they actually write it like this. SQL changed it to put the word joins and stuff. Now, don't get me wrong. I prefer the word join because it's a little easier to read and I like that. But this is not necessarily a horrible thing. Now, the one caveat I'll put into this as well too, though, is that I have heard of Microsoft bugs being filed that Microsoft doesn't work properly when you do a left join like this. That there's certain conditions that'll cause it to return the wrong data because of something they did. So, and I've heard that Microsoft plans to deprecate that functionality at some point in the future. Now, what? It's already deprecated?
2008.
Okay, so it's already deprecated. So there's the two reasons that you want to start moving away from this. But the best thing you can do is starting to modify them to be actual joins to get into them. Did you have something? I thought you were raising your hand.
So is there an actual performance impact, assuming that it's just inner joins?
No, and the real reason is because if you took an execution plan of this and you translated it, it would look exactly the same as the execution plan for the other one. So SQL does know how to interpret this and use it properly. It's not going to have a difference between the two. But readability and deprecation and things like that, you should start moving away from that syntax. Okay? It's not a bad idea to know it. If you're ever going to play with another database system, they use that. You know, and like I said, I know that because I've used other ones and I've had to write it like this.
I went through and scripted out all my databases, all of the functions, all of the triggers, everything, changed mine.
To not use this?
Not use those.
Yeah.
Because we were going to 2008 and one of them compatibility.
Yeah, so I would move away from it. I would not stay on it. I would use the join statements for readability, but are you going to see a difference? You should not see a difference between the two. Unless, the only time I'll say unless is that if somebody puts in here star equals instead of equal, then, and they didn't mean to do a left join, that's the same as if you would have said left join. Same thing. Yes, Mike?
So if somebody's writing code, let's say in C# and doing that style, is that converted when it comes over? I mean,
Well, it depends on what you're talking about. If you're writing in C# and you're just passing that, this is my query and here it is, no, you're going to see the query like this in Profiler. You're going to see it exactly like this. What I'm saying is when SQL Server evaluates that to build the execution plan, it does the same evaluation as if you wrote the word join. It knows how to translate between the two. But will you see this in your Profiler like this? Yes, absolutely. I still have these in my database from some old Delphi code. We have Delphi code that sends this across this way too, and it has the same thing. You can see it just like that. But the execution plan it generates would be the same execution plan if I typed it in. Should be. I mean, again, maybe that's the bugs that Microsoft's trying to get away from, but it should be the same. You should not see performance differences. Okay. Other query optimization questions, comments? Cursors, we all have cursors. Remove cursors whenever you can. Not because they're inherently bad, just because they're a loop, so you should avoid loops. Temp tables, CTEs, table variables. Okay, so personally, I like temp tables. I like temp tables because I can create indexes on them and because I've been writing them for way too many years. So it's out of habit. Many people like CTs now. They're much more of the common thing that's seen out there. I usually have to use a table more than once, and a CT can only be used once throughout a proc. So, but they're very nice. No, it can be used as the next statement. What?
They have their place.
Yeah, they have their place. No, it can only be used on the next statement. After that, it's gone.
Really?
Mm-hmm.
Okay.
Yep. Table variables. Table variables are not held in memory. Don't let anybody tell you that they are. All objects sooner or later live inside tempdb. When you put an object inside tempdb, it lives on a disk somewhere. That's the way SQL Server works. So when people used to say to me, well, table variables are in memory and temp tables are not, I'm like, no, they're not. They're both on disk somewhere. As a matter of fact, they're in the tempdb database. If you'd like to go look them up, feel free. You can. So a lot of people write table variables, though, because they're more used to it or they're used to code, and that's kind of a common practice. I wouldn't say there's too many pluses and minuses to either of them. Again, you can't index table variables, and I tend to index my temp tables. But I do a lot of performance work where I'm doing a lot of work before my joins or before my things. When you do that, indexing your temp tables makes sense because you're making a new table. So my preference is temp tables, but there's nothing wrong with using a table variable, and there's nothing wrong with using a CT. Just find the right tool at the right time. I'm not against any one of them specifically. I would look at them. If somebody came to me and said, I've got a table variable in here and they were putting 10 million rows in it, I'd always question. But I'd question that if they put a temp table with 10 million rows in it, because I'd say, okay, are we doing a little too much in this one proc? Should we maybe break this apart or do something else? So keep those things in mind. Like I said, follow your fat arrows and it will always tell you exactly where your problems are. That's one of my favorite things about the fat arrows. All right. So let's see, what other things? Large table joins, that's why I say follow the fat arrows. Know your row counts. I've got a little process in the back of mine that counts all the rows in my database, and I go and search it. I use ClickView, but I search it so I can find what size of my tables are. I mean, you can look it up in properties, but I have a lot of databases. So it's just easier for me to find them because I want to know if somebody's making a new table or a new query, and they're joining to something with 10 million rows, which is common in my database, I need to know about that. I need to know, okay, do we need to give this a little more attention than something with 1,000 rows? Because those things will come up. So look for those large table joins. You can find those by following the fat arrows and find out where they are, okay? Let's see, that's it for that one. So as you're making adjustments to the procedures, as you're doing things, take a step-by-step approach. I can't stress this enough, and I speak from experience. I have modified 20 lines inside of a store proc and then had no clue what actually made an impact. It ran faster, but I didn't know. I do not suggest this to anyone. I suggest you try to make a change, you check it in, make another change, check it in. Whenever you're performance tuning, try to do an iterative approach. You'll be very thankful for it because you'll know exactly what made the difference. And you'll get better because of it, all right? And make sure you test. I have a lot of people that say to me, well, I just go ahead and make the performance tuning in production, or I'll change the index and it'll be fine. And then 3 days later, something fails because of a performance tuning improvement you made. I would definitely retest anytime I make a performance tuning improvement. Make sure you know how many rows the procedure did beforehand and what they were and what they did after your change as well. Because most of your changes will be benign. They will not affect how it actually looks, but at some point you have to redesign them. And when you redesign them, it has to return with the same results it did before. So that's when you have to be sure of that. Okay? Questions about adjustments? No? All right, external tools and resources, SQL Century Plan Explorer. Again, I showed this, cannot emphasize enough that it is a wonderful tool. If you really like it and you want to look at great performance monitoring tools, they have a wonderful suite as well. If you're looking to buy a package or anything, they're one of my favorites. I really love SQL Century. All their tools that they have are really good. So that's my plug to them. There's a bunch of blogs up here. SQL Server execution plans, just search for that. Grant Fritchie's book is an excellent book on SQL Server execution plans. I can't remember the name of it exactly, but if you look for Grant, you'll find it, Scary DBA. And then what was the last one I had? Yeah, Scary DBA's blog post on it. Other questions? Oh, I'm over time. Not that we have a lot of time. Questions, performance tuning in general. Comments, things that you've tried that have not worked. Way too quiet of a group. Yes, Mike.
I don't know if this performance tuning. Sorry. Deadlocks.
Deadlocks, I just got done fighting those. Yes.
I'm fighting them right now. I'm a little bit of a crutch because I've got a monitoring system that's showing me the deadlocks. I go in and see that. Now I'm talking to somebody else, well, you're looking at the deadlock graph.
Mm-hmm.
And I'm like, I don't know. What about deadlock graphs?
So deadlock graphs are wonderful. They're the best way to look at them is by doing a profile and actually looking at the deadlock graph. And there is a post from Redgate. If you search for deadlock graph reading, I just found this 2 nights ago because I was looking at the same thing. And they explain all the pieces to it. I say, here's on the left, here's what you get, here's what you show. Now, the big problem I had is that I did a deadlock graph and mine would not show me the victim. They would not show me the query. It would show me what the deadlock was, but it wouldn't show me the victim. It was really annoying. So it showed me all the pages. It showed me every key that had locked and everything about it, but it wouldn't show me the victim. So it was a real pain in the butt trying to find out exactly what went wrong. So definitely look up the article, Redgate deadlock graph, and they walk you through exactly how to read the whole thing. It's a perfect article for that. The bigger thing about deadlocks is know that you have to you almost 99% of the time have to redesign something to get them to stop, because you have created a concurrency situation that you're going to have to get out of. So that may be that you have to change locking behavior, begin transactions, you may have to change that, but you're going to have to change something. It's not just something you can flip and say, now it's not going to deadlock. So usually no. Yeah, not with that one. And a lot of the times it's because people are using SQL Server as a queuing mechanism. What our situation was is we had 5 application servers over here. They all use one table to manage their queue. And all 5 of them are trying to hit the same queue, the same store proc. Whenever you're running into a queuing situation with SQL Server, you're going to have deadlocks. It's not designed to be a queuing mechanism. If you need a queue, go find a queue. Don't use SQL Server. So, but people do it, and you'll run into it. And the best thing you can do there is get it down to row lock and hold lock as best as possible. Begin your trans, get very specific about what you're updating, and then try not to update the same that someone else is doing as well. You can minimize them.
And maybe try to move to Hackathon. It solves a lot of that stuff.
It just removes locks. Honestly, I wouldn't suggest.
It queues differently, like it.
Well, it doesn't maintain locks.
Way cool though. It just
Yeah.
It doesn't. So well, that's why
My first suggestion is not to go to an enterprise edition just to handle queuing, when you can go to RabbitMQ, you can go to Microsoft MQ, you can. There's like 100 queuing products out there.
They're already on like enterprise edition. Upgrade, you know.
Okay, there's one solution.
In order to have deadlock graphs, you have to enable a trace log for that too.
Not if you're profiling. If you're profiling, it's just a setting in your profiler.
Okay.
So if you open up Profiler, if you know this is happening, you open up Profiler, there's a little box, I think it's under locks, and it says deadlock graph. You just check that. You check a few things, statement completed, statement beginning, so you make sure you get all the pieces, and it'll just spit out a graph. And you can actually tell them in there's an advanced tab, and you can write them to a folder. I can actually show you mine, because like I said, I was just doing this.
So did you start calling your
So
victim
you have
John
to
Doe?
catch the deadlock.
You have to catch it, yeah. So,
Thank you, Lars.
Yeah.
so this is what it creates, is this little thing right here, and then there's your graph, exactly of what it is. Mine, you can't see it very well. But yeah, it creates your file right there of what your deadlock is. And so Profiler can do that. Now, if you can't capture it at the time, if you can't profile it, yes, you have to turn on the trace flags to do that. And Jonathan Cahias has a wonderful blog post on what to turn on and how to read those as well. What?
Yeah.
Well, there's 2 of them. There's one that does it that way, and there's one that does it
Just
another.
you're talking about the SQL block.
Yes, yes. So yes, if you can't capture them at the time, like this with Profiler, you have to use that. You have to use the SQL block.
Spotlight does that for me.
Okay.
So that's a crutch. I won't know how to do that.
Yeah, if you want to,
to.
profiling it to me was an easier way to do it. The ones that go into the SQL log, they're hard to read too. They're not simple. They're a pain in the butt. Like I said, Jonathan has the best article on reading those though. So luckily mine, I could completely reproduce because we knew exactly what was going on. So we just threw it down into staging and did a run through, and we just profiled all these out.
Does he end up using extended events instead?
Does he use what?
Does he use extended events?
Not for that one. Not for that blog post where he's just talking about in the log. The log is just doing that, but extended events also can do it. But I don't think they can give you the graph. They can tell you what deadlocks are going on, but they can't give you the graph, I don't think. Not yet. Maybe in the future. Did you have another question?
Oh, just, we found that when we turned on RCSI, that did tend to reduce them, depending on exactly what kind of ones you had.
CSI, what do you mean by CSI? Oh, yes. Yeah, so that can definitely make a difference too. You can do a different isolation level, but again, that's where I said my key comment there is you have to change something. This is not something that'll just disappear. This is not something that a lot of the time indexes may help, but they may not completely resolve it. And then you may have to go to something like a whole snapshot isolation level that changes everything. So, but keep those things in mind. If you're queuing in any way in SQL Server, sooner or later, you're gonna run into deadlocks. You're using a system what it's not designed for, in my opinion, unless you have Hackathon. And then Andrew will do it for you and you'll be fine.
We have enterprise, and we also use RabbitMQ.
See? We have RabbitMQ for another system that we designed, but we still have a lot of queuing in our SQL Server that we're working on getting and migrating it. So, okay, I did not have anything else. So,
Question.
yes,
Order of operation, back to that,
yes,
in the where clause,
yes,
is it top down or bottom up?
yes. In the where clause, order of operations is top down. SQL Server basically is always left to right, top down, whenever it does the things that it does. So, yeah, and that brings up an excellent point. Thank you for mentioning that. Put your most filtering things, I forgot the exact, selective, thank you. Put your most selective things at the top. If you say, this can only be if this column is equal to 10, that's a very selective thing that should be right at the top to limit it down. Always try to order that so that whatever's the most selective is at the top, because it will help with performance. I mean, you what? Start with an or clause? No, don't start with an or clause. Or a like percent, you know. I've seen that though many times. They'll have a like percent with an or something else, and then at the bottom it'll say, oh, and I only want to see everybody that's respondent type 2. And there's like 100 of those. And it's like, if you had done that first, it wouldn't have had this problem. So you can actually change. If you look at the execution plan, you can change a scan to a seek based on your where clause sometimes, because of the order that you put it in.
Is that the same in the from statement as well? Put your smaller tables at the top?
Yes. Everything, again, everything is top down, left to right, standard idea. Yes.
And I've been told, this has never happened to me, that if you're being lazy and you're doing select and choose, if your data does get too large, you're actually suffocating time, work, because you're going to force a cache.
Yeah.
Not that I've done that.
So select intos, that brings up a good point. What I usually say for select into is when I'm designing something or developing, I'm working on something, I use a select into. Once I move it to production, I usually use a create table, and I do that beforehand. It doesn't exist anymore, but back in 2000 and 2005, there was a nasty bug that if you did a select into and it was too large, it locked your tempDB. It slowed everything down on the server. And so I wouldn't suggest select into inside production running procedures. If I have something in production, I usually say no, create table first, and then do my select into. So good point.
I don't get candy for that. No.
Is there what?
He wants candy.
Yes. Okay, everybody else duck.
I just want you to make everyone else stop.
Who else needs candy? Nobody's gonna raise their hand. Okay, well, there's plenty of snacks back there. Would you like some more? Okay, otherwise I am complete. I will be around for questions. Otherwise, thank you guys very much for coming. Have a good afternoon.
Let's see if we lost the recording is the better question.